Ask 3 suppliers for a fan, a blower, and a compressor, and you may receive 3 machines that overlap. The names are not separated by one universal pressure number. The useful way to understand them is as a pressure rise and gas compression continuum. In the next 4 minutes, we will place the labels on that continuum, compare the mechanisms, and build a specification that cannot be confused by product names. All 3 machines add energy to a gas. At the low pressure end, a fan usually moves a large volume of air with a relatively small pressure rise. HVAC supply fans, cooling fans, and many axial fans live here. Density changes through the machine are normally small enough that performance is commonly described by airflow and static or total pressure rise. Move along the continuum and the term blower becomes common. A blower usually implies more pressure capability, a more defined inlet and outlet, or a packaged centrifugal, regenerative, or positive displacement mechanism. But geometry does not create a universal border. The same scroll-housed centrifugal machine may be sold as a centrifugal fan in one market and a blower in another. At still higher pressure ratios, gas compression and temperature rise become increasingly important, and the word compressor becomes more appropriate. This is why pressure ratio is more useful than a name alone. Pressure ratio is absolute outlet pressure divided by absolute inlet pressure, not gauge pressure divided by atmospheric pressure. Consider air entering at 101.3 kilopascals absolute. Add 1 kilopascal and the pressure ratio is about 1.01. Add 10 kilopascals and it is about 1.10. Add 100 kilopascals and the ratio approaches 1.99. These examples show a continuum, not mandatory naming thresholds. Standards in industries can define their scope differently. For example, one ASME blower system test code covers blower packages used at pressure ratios up to 3. Mechanism is the second clue. An axial fan keeps the main flow direction parallel to the shaft and is efficient for high flow at modest pressure. A centrifugal wheel accepts air near the axis, accelerates it radially, and often uses a scroll or diffuser to collect flow and convert velocity into pressure. A regenerative blower repeatedly transfers momentum around a side channel. A positive displacement blower traps and transports discrete volumes. Those mechanisms create different curve shapes, noise, pulsation, contamination tolerance, and control behavior. Now compare 2 duty points. A ventilation system may need 12,000 cubic meters per hour at 600 pascals. A combustion air circuit may need 200 cubic meters per hour at 8 kilopascals. Calling both devices a blower reveals almost nothing. Plot the required airflow and pressure on each tested curve. The intersection with the system curve determines the real operating point, absorbed power, efficiency, and motor margin. The pressure definition must also match. Static pressure and total pressure are not interchangeable. For higher pressure ratios, density, inlet temperature, gas composition, and compressibility become more important. A gas appliance blower also needs appliance-specific safety validation. A visually similar fan is not an automatic replacement. When specifying the machine, start with airflow, pressure rise, and whether that pressure is static or total. Then state inlet absolute pressure, temperature, gas composition, contamination, duty cycle, control range, sound limit, installation geometry, power supply, and required test method. Add the complete performance curve, not only one maximum value. So, what is the difference? Fan, blower, and compressor are useful families, but their boundaries overlap. Pressure ratio describes how much the gas state changes. Geometry explains how the machine creates that rise. The tested curve proves whether it can serve your system. Select from the duty point outward, never from the label inward. If you want one fan or blower duty checked, send Longwell the airflow, pressure definition, gas conditions, voltage, control, and installation drawing. We will identify the suitable mechanism before recommending a model.